Assalamualaikum and hi to my beloved lecturers and my fellow friends. I'm Nur Syafiqah bin here from Group 6.
Assalamualaikum and hello everyone. I am Haidarul Amar.
Hi and Assalamualaikum. My name is Kisina Uzma.
In this presentation, we will cover introduction, objective, problem statement, literature review, workflow, methodology, project outcome, seismic stratigraphy, and conclusion for this project. So for this presentation, I will take part for the introduction, objective, problem statement, and literature review. The introductions. We are from Group 6, pursuing degree in Petroleum Geoscience. This project is aligned with QCB 3023, which is seismic interpretation subject that we take for this semester. Seismic interpretations is the principal course that is essential for future geologists and especially for the future geophysicists. We are currently working on the Bundi field in the Malay Basin. We utilize the Petrel ENP software platform for this project. This software is developed by Schlumberger, and our focus is to interpret the top F at source Bundi, and F5 in Bundi 1 is assigned by the lecturer. The next slide is objective. In this lab project, we will cover 4 objectives, which are data loading and familiarization, second, peak horizon and faults, third, convert horizon map and depth map, and fourth, to interpret the Bundi well using the Petra. The first objective is data loading and familiarization. We need to learn how to load seismic data in Petra and to differentiate between inline and X-line. Inline is a horizontal line and X-line is the vertical line. And then the second one is we need to pick horizon and fault from the interpretation window. And then the third one is convert horizon map and depth map. We need to create surface map and depth map, and we need to learn how to smooth up the spikes in the surface map, because if our surface map have so many spikes, that means our picking horizons is totally wrong. And then the last one is to interpret the Bundi well using the Petra. We move to the problem statement. In this lab project, we will have 4 problem statements, which are how to load data in Petra, how to pick horizon and fault using Petra correctly, and how to create surface and depth map using Petra, and the last one is how to interpret the velocity map. Last part for my session is literature review. For this part, I will share with all of you overview of Bundi field and Malay Basin. The first one is overview of Bundi field. Bundi 1 is a wildcat well drill by ESO Production Malaysia in cooperation in Block PM5. It is located approximately about 280 km north-northeast of Kemaman Supply Base. In those studies, the well data that were produced by Bundi and South Bundi shows both wells are gas fields. The drilling operation terminated at 2,784 meters and the well was abandoned on 1st March 1991. Bundi prospect shows low relief and decline structure and is a part of fault band fault. Our study area is indicated by red mark in Malay Basin. So now we move to the second overview, which is Malay Basin, because Bundi is located at the Malay Basin. Malay Basin is situated at southern part of the Gulf of the Thailand and at the offshore of state Terengganu. It covers an area about 80,000 km square. The basin are filled up to 14 km of sediment that I got from the article Abdul Rahman Muhammad Arshad. And for the water depth is about less than 200 meters, and this location is considered as shallow water. And then for tectonic events that lead to the formations of Malay Basin are extension during the late Cretaceous to early Miocene, thermal subsidence during early Miocene to middle Miocene, and then the last one is compression during late Miocene to Paleocene. So I will pass the floor to Christina.
Next, we move on to the methodology for this project. In this methodology, we start by the loading of data of the Bundi and the sub-Bundi well. We generate the 2D and the 3D with seismic window, and also we import all the well data such as the well head, well top, and also well log. Then the velocity data, which is the check shot, and also the seismic log calibration. After that, we move on to the synthetic computation, and then we go to the seismic calibration, and then we do the horizon picking. In this horizon picking, we do it on the interpretation window in increment of 50. We do the horizon picking in inline and cross line alternately. And then, when do the horizon picking, the picking will be stopped when the horizon meets the fault surface. Next, we do the fault picking in the interpretation window. We identify all the fault picking by the increment of 10 to make sure that we didn't miss any fault. Then we generate the surface map, and then we converted the time to depth map using the velocity. And then we can proceed to the interpretation by looking at the interpretation window. In this interpretation window, we can identify the three things that we will interpret and we will explain later in the seismic stratigraphy, which is the structural, the sequence stratigraphy, and also the channel detection. Then we go to the proceed to the project workflow for this project. As you can see in our Gantt chart, during the week 2 until the week 6, we have been briefing on how to use the petrol by our beloved GAs, and then on the week 7 we have been divided into a few groups, which is each group consists of 3 to 4 people, and each group has been assigned to their own task, which the group 6 has been assigned to interpret the top F of the Bundi field. Next, on the week 8 and week 9, we do all the data importing and also the data calibration. On week 10 and also week 11, we do all the data processing, and to make sure all the data processing that we do is correct, in order when we do the interpretation, it will not affect it. Then on the week 12, we have been focusing to the presentation. That's all for our project workflow for this project.
Now, we move on to the results and discussion from the map that we obtained. From the results that we get, we know that the area of deposition of sediment and environment of top F is coastal fluvial plain environment with varying tidal influences, since our formations are deposited during the middle to late Miocene. As the highlands erode due to weathering and water flow, the sediment from the hills is transported to the lower plain. Various creeks will carry the water further to a river, lake, bay, or ocean. Our top F and F32 in South Bundi and Bundi 1 are deposited in ocean at Malay Basin. As the sediments are deposited during flood conditions in the floodplain of a creek, the elevation of the floodplain will be raised. The composition of the horizon area are alternation between shale and siltstones, with minor sandstones bed. This is the petroleum system formation for Group F formation. Our area dipping to southwest direction because of the strike angle, which is perpendicular to the dip direction. Thus, our area will be steeper to the southwest direction. The fault more concentrated to north-northeast and south-southwest map because our sigma 1 is the highest at the top, and our sigma 3 will be decreased in the horizontal part. Thus, the fault will appear more there.
In this seismic stratigraphy section, we have been identified into 3 things, which is the structural geology, the seismic stratigraphy, and also the channel detection. We move on to the first thing, which is the structural geology. Structural geology is a study of the 3-dimensional distribution of large rock bodies of their surface and the composition of their interiors in order to learn about their tectonic origin, the past geological environment, and also events that may have altered or deformed the formation. The structural geology deals with the geometric relations of the rocks and also the geological features in general. This can be dated to determine when the structural features are formed. So, in this top F, we have identified two things, which is the faults and also the pockmark. We move on to the fault. Fault is a flat fracture or discontinuity in a volume of rock which there has been a substantial displacement as a result of rock mass movement. A large fault within the Earth's surface, Earth crust, has arisen from the action of plate tectonic forces, with the largest of them defining boundaries between plates, such as subduction plate and subduction zones, and also transformation faults. As you can see in the diagram, we found out that there are a total of 6 fault planes are found in the top F. All the faults are normal and also reverse fault. They are found in the direction of the NNE and also SSW area of the map. There are 3 faults that we found in the X9, which are the number 1, 2, and also 3, while others are found in the inline. As you can see in these reading faults, we can determine that the fault number 1 is the longest fault, which is the 6,933.507. It also had the biggest displacement among the other fault, which is the 0.038 meter. Next, we proceed to the pockmark. The pockmark is an indication of the gas seepage, which means that the gas is present in the top F. As you can see in these two diagrams, in a post-drill well evaluation report by ESO Production Malaysia Incorporated, 9JA and also Wally DS on 1992, they state that the most of the top reservoir were found to be a gas bearing. It is proven when we found the pockmark features, such as the diagram before, in the seismic session. We also have do some the literature review that prove our interpretation of the pockmark is based on the Kelly JT and also Dixon SM Belknap, DF Barhart WA and also Henderson M on 1994. In their journal, they states that the circular depression or pockmarks are originate from the biogenic natural gas and pore water that seep up from the surface. Aligned with that, based on Hovland and also June on 1988, they are roughly conical depression that form from the escape of the natural gas and interstitial water from the muddy and unconsolidated sediments. Next, we go to the sequence stratigraphy. Stratigraphy is a science of recognizing the difference in the successive layer of character and structure of the rocks. The sedimentary rock layering is expressed of a series of easy to complex sedimentary geometries and a wide range of different sedimentary phases. Sequence stratigraphy is a branch of sedimentary stratigraphy that deals with the order of sequence in which depositionally associate strata succession units that have been formed in the available space. It is also improved the methods for predicting the well-controlled reservoir, source, and also sealing phases. So, as you can see in this diagram, we have found out the progradational, which is the oblique. As you can see in this diagram of the pattern, the reflector of the top lifting and also the upward building into a basin. These oblique patterns are indicative of sedimentation rates and commonly it contains of clean sand in the upper portion of the bedform. These oblique bedform types are typically require of water depths between 500 meters or more. The environment of deposition has lower slope and slumps, or it might be has large lithified collapse blocks. Next, we have found out also the simple, which is the parallel pattern. As you can see in this diagram, it has an uniform deposition of continuous reflectors. It also has the high amplitude and also low frequency. It also has the continuous reflection, as you can see in the diagram. The continuous and draping are the underlying the topography. So we can determine that the EOD for this parallel is pelagic and hemipelagic. The last one is the channel detection. The channel detection is we can see as the depression-like features show the presence of the channel in the seismic reflection. These channels are expressed as the negative relief features that truncating the underlying strata. As you can see in this diagram, we can see that there is a meandering river on the top part of the diagram. It has been proved as you can see in the seismic interpretation window and on the number 1, 2 and also 3 that there is some indicating features for the channels of meandering. Meandering formation is due to the bulk deposition and erosion when the meanders also gradually migrate downstream. The force of the water erodes and undercuts the river bank on the outside of the band where water flow has the most energy due to the decreased friction, and this will form the river cliff. On the inside of the band where the river flow is slower, the material is deposited as there is no more friction, and this will form a slip-off slope. So it has been determined by the surface map of this diagram. So that's all for the seismic stratigraphy. Thank you.
Now, let's move on to the conclusion. Due to its location near the estuary, the depositional environment for this Group F is lower coastal plain with tidal and marine influences. As we all know, this basin, which is called Malay Basin, is an important hydrocarbon area in Malaysia. The structures that can be found in Group F are shales interbedded with siltstones. As there are more shales than sandstones, it does not have the best reservoir quality due to the bad porosity, but there are still some accumulation of hydrocarbons. Furthermore, compression occurred, and this led to a formation of groups of faults. The type of faults are mainly normal faults.